In this chapter, we are not going to calculate a lot of things, but I simply want us to be able to interpret the amounts that we calculate using stoichiometry. But before I get to the interpretation of amounts, let us speak about a hypothetical reaction. So we will always have reactants that will come together to give us products. So now there are terms that are associated with the amounts of reactants. So let us say you use stoichiometry to calculate an amount of a reactant. So it is useful to label that amount of a reactant to say it was used or reacted. Again, let us say you have calculated an amount using stoichiometry, an amount of a product. So it is more useful to label that amount formed or produced. So if I speak of an amount in this chapter, I'm simply referring to the mass of that substance or the number of moles or the volume or the concentration. That is what I refer to by amount. Now, what was I saying? I was saying that the amount of a reactant calculated or given must be labeled used. Okay? I will tell you later on why do we need these amounts, the used amounts. So now any amount of a reactant should be labeled used. Let us take, for instance, let us say we have hydrogen, and let us say hydrogen was a reactant. So if we have calculated the volume of hydrogen, who is a reactant, we need to label that amount used. So 2 decimeter cubed of hydrogen was used if hydrogen was a reactant. In this case, we have the mass of oxygen, who is a reactant. So 10 grams of oxygen was used. And why do I use the term used? It's because we're speaking about a reactant. And then same thing with the product. So if I have water, and water is a product, so any amount of water that has been calculated or given, so must be labeled produced. So now we have the number of moles of water, which are equals to 2.01 produced. And why again am I using the term produced? It's because we are speaking about a product. Now let us look at other terms of amounts, different types of amounts. Other types of amounts can be initial amount, it can be final amount. So let us define each. An initial amount is simply a present amount before the reaction. So a reaction is necessary because we're speaking about stoichiometric calculations. We need a chemical reaction or a chemical equation. So now whatever we have before the reaction, we call it an initial amount. Remember, amount refers to the mass, the number of moles, the volume or concentration, if you want. And then we have what we call a final amount. So other words that are equivalent to final is excess amount or remaining amount. So what is final or excess or remaining amount? This is the present amount after the reaction. So after the reaction has completed, how much is remaining is what we call a final amount. So I want to mention that these two cannot be used in this formula. Remember, we use this formula for stoichiometric calculations, and we don't use these two amounts, the initial and present amount. Let us read this first line. In this formula, we use the used or produced amounts. So only the amounts that are labeled used or produced can be used in this formula. But the amounts that you have, let us say you have a question that you're answering and it begins like, initially 3 moles of hydrogen and 4 moles of hydrogen are present. So those are initial amounts. We don't use them in this formula. And let us say the question continues to say, after the reaction is completed, it was discovered that 1 mole is remaining. So whatever remains or whatever was present initially, we do not use it in this formula. So now in this formula, we use the used amounts or the produced amounts, not the initial, not the final. But we can use the initial amount at a given condition. So we can use the initial amount only if and only if it was completely used up. They can say to you, initially 3 moles were present before the reaction. And it was discovered that all those number of moles were completely used up. So you can use those number of moles because there was this mention. Those number of moles were completely used up. So the initial can only be used in this formula if it was completely used up. I hope that makes sense. So I'm going to proceed. I want to explain what I'm saying here. So I'm going to put this just on the side. And I want to have this. So now I want us to identify the initial amount, the final amount, and the amount that we're going to use in stoichiometry. Remember, I said we don't really care about the initial or final in doing our stoichiometric calculations where we compare using ratios. We want to use the used amount or the produced amount. So I have a graph of zinc, the mass against time. So we can see that as time progresses, we are losing the mass of zinc. That means zinc is being used up. Okay, so we are using zinc. That is why I'm calling zinc a reactant, because we are losing the mass. We are losing the amount. So our amount of reactants are always used. So if you look at this graph, it will always decrease like this because our reactants are not formed. Only products are produced or formed. So only a graph of a product will increase. But a decreasing graph is always a graph of a reactant. Now, we have the mass against time of zinc in a chemical reaction. So let us identify the initial amount of mass of zinc. So initially we look at T0. So we're going to look at a point on the graph that is at T0. So this is where our graph begins. What is the initial mass? What do we begin with? So the initial mass here is 30 grams. And what is the final mass? We can see that the reaction is complete here. Why do we say it's complete? Because our graph is now horizontal. It means we have reached the completion of this reaction. So finally, we do have the final mass after the reaction. So the final mass after the reaction is 20 grams. Now let me ask a question. Do we use this amount or that amount in stoichiometry? No, we don't. I said we don't use the initial amount or the final amount. Unless they say that the initial was completely used up, we can use it. Also remember that this formula only calculates the number of moles. So if you have the mass, you need to proceed and calculate the number of moles. Now, let us calculate how much was used. So I have the initial, I have the final. So we can see that the amount that was used is actually between 30 and 20. So how much did we use from 30 all the way to 20? So that means we used 10 grams. So 10 grams was used. So now this mass should be used to calculate the number of moles, and only this mass will proceed to be used in this formula. Because as I did say, we only use the amount that were used or produced, not initial, not final. Okay, let us look at the second graph. So that means here, this amount was in excess. 20 grams was in excess. This is what we began with. And this is what we're using in our stoichiometric calculations, the difference between initial and final, always. Now, let us look at this graph again. Zinc is a reactant. How do you know that this is a reactant? Because our graph is decreasing. We said we're always using our reactants. That is why the graph will always decrease like that. But if you're talking about a graph of a product, it will be the reflection like that. Now, this graph is the graph of volume against time. So we can see that as time progresses, we are losing the volume of zinc present. What is the initial amount of volume of zinc? So we begin with a 30 decimeter cubed because it's a volume. So initially we have 30 decimeter cubed. And then finally, how much do we have finally? Finally, we have 0 decimeter cubed. So how much was used? So we used 30 decimeter cubed. So now can you see that the initial amount was completely used? This is the only time we can use the initial amount because it was completely used. How do you know it was completely used? We have nothing remaining. but here we have 20 remaining. There is the difference. I want to get rid of at least one of these. Okay, and I want to have this here. So now how do we calculate the amounts that are used? So how do we find the strain? So now to find the amount used, you're going to use this formula. You're going to say the final amount minus initial. Do you remember how you find change? So we're simply calculating the change in amount. You say final minus initial. But why do I have a negative? It's because we are losing this substance. We are using it. So if you are using up a substance, we denote the loss by a negative. Okay, so we are losing the substance, so we're going to say a negative, and then we open a bracket, and then we calculate the change in amount by saying final amount minus initial amount. Remember, the amount can be mass, the amount can be volume, it can be the number of moles, it can be the concentration. These graphs can change amounts. So in this case, our amount was the mass. So what do we say? It's the negative mass final minus the mass initial. So now this is a negative. What is mass final? The mass final is actually a 20 minus the mass initial, which is 30. So this value will end up being negative, and that value will end up being positive. So we're going to have 30 minus 20. So the answer should always, by all means, ensure that the answer is positive. The answer for used or produced, it should always be positive. So we understand that this is used. And then again here, the amount produced. The amount produced, why do I have a plus? It's because we are gaining this amount. It is being produced. So simply right away, you're just going to say the final amount minus the initial amount. Not just number of moles. It can be any amount. This can be the mass, it can be number of moles, it can be volume, it can be concentration. So that is what you'd have to do. You put a plus for products, you put a minus for reactants. Why a minus? Because we are using up our reactants. So now, the answers that you get from these formulas are the answers that will proceed to this formula after you have the number of moles. We don't work really with final or initial, but they used or produced answers.